Hi guys, just wanted to discuss the Module 4 exercises that we were assigned. The first three dealt with definitions and the difference in between the terms. Dense index, sparse index, clustering, non-clustering, primary and secondary indexes, and then closed and open hashing. I thought that was all good exercises as a reminder of what these were and to cement in our heads how to differentiate the different terms. The next question had to do with why a hash index would be inefficient given range queries are executed on your database. Range queries obviously would be more efficiently executed if your data was stored in some sequential format or indexed on a sequential format. So hash function by its nature is not indexed sequentially, so it would make it difficult to find all items within a range. For the next question, I thought was the most difficult, deals with encrypted data and how you would create an index on the encrypted data. Everything I saw online that I could read pointed towards giving away some information about what the encrypted data actually is. Like, for instance, you could use an encryption method that would store the encrypted values, in a format that matches the sequential order of the actual underlying data itself. And then just creating an index on the encrypted value. That was one of the more difficult ones that I found. Maybe someone else came up with a better solution than that, or has a better solution for that. 11.26 in the Module 4 exercises. For the practice exercises, all the answers were given for us, though I tried to go through and look at the question without looking at the answer and come up with my own answer. And I actually constructed the B trees myself, and then went through and created the extendable hashing structure or diagram from the values given. One issue I had with that was when I tried to take the binary output of x mod 8. I started from the right-hand side instead of the left-hand side, and it gives a totally different result than what they give as the answer in the answer key. But I actually then went back and started from the left-hand side, and it all worked out to the exact same answer they had. So I got the concept down, just a different approach. I guess there's two different ways of doing it there. I don't know if anybody else ran into that or not, but then the last question I thought was the most difficult again for the practice exercises. 11.10 talks about for extendable hashing, you have a bucket address table, and they wanted to know when you could reduce the size of that bucket address table when buckets are coalesced or they're deleted, and when should you actually reduce the size of the bucket table. And they want to keep some kind of index or some kind of a number or integer on with the bucket address table to know when to reduce the size. They want to know an efficient method for that. I thought of keeping a 1-bit flag with each address to denote whether or not the address is pointing to a bucket using all I bits of the common hash prefix. So whether that would actually be efficient or not, and I know that's a different answer than what the answer key gave, but I think it would work and be pretty efficient. You can just check to see if any flag bits are 1, and if they are, then you can't reduce the size of the bucket. If they're all 0, you can reduce the size. So that's just one method. I think, of course, the answer key gives 2 other methods that you can use. But anyways, I thought they were excellent exercises, and I'm having fun with class. Thank you.